Good day, students. How are you doing? This is me again, Mr. Michael Navarro, and welcome to my YouTube channel. In this video, we're going to talk about arithmetic series. Let's have a short review on arithmetic sequence first before we proceed to the discussion. Okay, let's complete the table below using the symbols from the given box to create a true statement. An arithmetic sequence is an increasing sequence if and only if the difference is greater than 0. An arithmetic sequence is a decreasing sequence if and only if the difference is less than 0. An arithmetic sequence is constant if and only if the difference is equal to 0. The first term of a sequence is notated as a sub 1. Some are using t sub 1 because it's term 1, but mostly it's a. The symbol for the general term of a sequence is a sub n or t sub n. Okay? Arithmetic series. So these are just some few examples where arithmetic series concept is applied. Okay, more specifically stacking objects. Okay, so for example, we stack cans, especially when you go to groceries, department stores. A store may stack cans for display purposes. Suppose cans were stacked in a pattern that is one can at the top and each row thereafter adds one can. So it's for example, in the picture here you have one at the top and then 6 at the bottom. Write the sequence generated by the number of cans in each row. So 1, then 2, then 3, then 4 cans, then 5 cans, then 6 cans, right? So if you're going to use the general term for the arithmetic sequence, this is the formula, right? And here we assume that a sub n is equal to n, or the general term is equivalent to the value of n. So for example, here our n term is 6, then our n is also 6. This is just an assumption. Would this sequence be finite or infinite? Okay, it's finite. If there were 18 rows in the display, how many cans would be in the 18th row? So if you're going to look at this assumption here, what could be the possible answer? Yes, it's 18 also. There will be 18 cans. How many cans in total would be in a stack of 18 rows? So if the first question is different from this one. I mean, this question is different from this one. This one is asking for how many cans are there in the 18th row. This one is asking for how many cans are there in a stack of 18 rows. Okay, so what strategies could you use to solve this question? The answer here is 171. You find that if you're answering it manually, it's okay. Later on, you can answer that one. What if the stack of cans had 100 rows? So if you solve this one manually, it's okay. But what if it's 100 rows? So it's 1 plus 2 plus 3 plus 4 plus 5 plus 6 and so on plus 18. The sum of the terms of an arithmetic sequence is called an arithmetic series. So this is an example of arithmetic sequence, but the sum of the terms there in an arithmetic sequence is what we call arithmetic series. Okay, so let's derive a formula for an arithmetic series. Solve a simpler problem. Consider a stack of 6 rows of cans. So 1, 2, 3, 4, 5, 1 plus 2 plus 3 plus 4 plus 5 plus 6, which is equal to 21. Given here, table, below is the rows, and then here the number of cans. So if you're going to graph this one here, shade in the number of cans per row. For example, first row there, and then second row, third row, fourth row, fifth row, and sixth row. What is the area of the shaded region? So you're just going to count the number of squares here. So 1, 2, 3, 4, 5, 6. So that's what we have answered here. It's 21, right? Then in a different color, shade in squares to form a rectangle. So what I mean is this one. So to complete the rectangle, what do you notice about the two shaded areas? Right? Okay, so it's rectangle man, so you don't stop here in 6 because it will create a square, but you're going to stop in 7. What do you notice about the two shaded areas? Okay, what is the width of the rectangle? So the width of the rectangle is 6. What about the length? It's 7. What is the area of the rectangle? So if you're going to multiply 6 times 7, that's 42. So what's the relationship between the sum of the area of the shaded part to the area of the whole rectangle? How is it that the area related to the sum of the sequence? So 42 and 21. You're just going to divide 42 to get 21, right? So it's 6 times 7 divided by 2. Okay? Use this idea to find the sum of the 18 rows of cans earlier. So 18 times 19 divided by 2 equal to 171. Alright? So the number itself and then multiplied by the number next to it. Then divide by 2. Okay. According to an old story, according to an old story, one day Gauss and his classmates were asked to find the sum of the first 100 counting numbers. Okay, so Sir Carl that time is so young. The story goes, he's still in grade 2, and then the teacher solved that problem for how many days? Because even you, if you're going to use a calculator, 1 plus 2 plus 3 until 100, you're still going to check if the one you type or encoded in the calculator is correct, right? You keep on moving backwards for you to check if it's really correct. But for Johann Carl Friedrich Gauss, he solved it on the spot. For the teacher, it takes around few days. For him, it took only a few minutes, maybe less than a minute. So this is the sequence. All the other students in the class began by adding two numbers at a time. Starting from the first term, Gauss found a quicker method. So he made a formula or derived a formula. So what he did is the one we derived earlier. So it's 100. Since it's the last term, and then we multiply it with the next number next to it, so which is 101, and then the product is 10,100, and then we divided it by 2. Therefore, the sum of the first 100 counting numbers is 5,050. So if we're going to derive the formula, for example, consider the sequence. So, and then we reverse the sequence, and then we sum these two: 3 plus 23, 7 plus 19, 11 plus. They will get the same sum, right? And then here we have 2s sub 6, and we multiply it. How many 26 are there? So there are 6. So 6 times 26. and then we separate the first. This is the first term, right? So which is S sub 6 is 78. So this is the first term, and then this is the last term, and then we divided both sides by 2 to isolate S sub 6 here. If you notice, this is the first term, and then this is the last term of the sequence. And then here, 6 is the number of terms in the sequence, right? 1, 2, 3, 4, 5, 6. In general, if you know already what's the first term and the last term, then you can use this formula. So you add the first term and the last term, then multiply it with the number of terms they have, and then divide by 2. The sum of an arithmetic series may be written as this one, when you know the first term and the last term, right? Okay, and then to solve for if you don't know the last term, you may use this one. Okay, this one. So this is just a derivation from this to this. Okay, so we simply substituted the formula here, right? Okay, so basically we just manipulated the part where you have to add those terms that are similar, like for example, a sub 1 plus a sub 1, this becomes 2a sub 1, right? And then here the same rules apply. S sub n this time is what we call the sum of an arithmetic series given the nth term, right? So the same variables are used. N is the number of terms, a sub 1 first term, a sub n last term, and and d, sometimes you're going to use d. The same d is the difference. Okay, so take note, this is the formula that you're going to use when you know the first term and the last term, and also the number of terms. Okay, but if you still have to find the last term, then this is the formula suited for your problem. Okay, so you have the first term, and then you need to solve for the last term. Missing the last term is missing, but you have the number of terms and also the common difference and the first term. Okay, so I think we'll have to continue to the next video.